Okay, good morning, everyone.
Good morning, sir.
Yes, so today we are going to start with our next topic, and that is second order circuits. Second order circuits, as we had already told, that if we have second order differential equation, then that circuit is called second order circuit. Okay, and how do we get second order differential equation? If we will have inductor as well as capacitor, both of them present in the circuit, then we are going to have, these are some of the examples of on this side we have these second order circuits. Okay, so let us see, before we start the analysis of second order circuits, we need to have some idea about initial conditions in second order circuits. Okay, initial values and final values. So there are two things that you have to consider. The first one, always in the circuit analysis, we must carefully handle the polarity of voltage. Okay, we should always follow the passive sign convention. Okay. Secondly, one should be carefully observe how these are defined and apply them accordingly. Okay. Second thing is, you have to keep in mind that voltage across capacitor and current in inductor, these are the things which will not change immediately. Other things can change. Okay, so now let us look at this circuit. We are saying this switch is closed for a long time, open at t equal to 0. Find I of 0 plus, V of 0 plus, di by dt at 0 plus, dv by dt at 0 plus, I infinity, V infinity. What is the meaning of di by dt at 0 plus?
Instantaneous change of current.
Rate of change of current at time t equal to 0 plus. Rate of change of voltage at time t equal to 0 plus. Okay. Now look at this circuit. We are saying this switch was closed for a long time. Okay. That means DC conditions are prevailing for a long time. That means capacitor will act like open circuit. Inductor will act like short circuit. So in that case, can you tell me what is the value of I of 0 minus?
2 ampere.
So that should be 2 ampere.
Yes, 2 ampere.
What should be V of 0 minus?
4.
4 volt. Okay.
4.
And we said current in inductor will not change immediately. Voltage across capacitor will not change immediately. Is this okay? Right? So these are my I of 0 plus and V of 0 plus. Next thing I am asking is, what is I of infinity and V of infinity? Can you tell me when this switch is open, this is gone? Now tell me what is I of infinity and V of infinity?
3 and 12.
I of
Sir,
infinity
0,
will be
0 and
3.
12.
0.
Sir,
0, sir.
0 and 12.
sir, 0 I of infinity.
0.
And voltage will be 12. Is this okay?
Yes, sir.
Okay.
Yes, sir.
Now tell me, how do you calculate di by dt at 0 plus and dv by dt at 0 plus?
Sir, how is I of infinity 0?
Because when you have infinity, this will act like open circuit, right? This will act like short circuit. So if the whole loop is open circuit, the current flowing in the loop will be 0, right?
Okay, sir.
Okay, so any idea, anyone, how do I calculate di by dt at 0 plus or dv by dt at 0 plus?
Sir, we will take capacitor as short circuited
Okay,
and the
capacitor as short circuit, why?
sir, because at 0 plus the charge on capacitor won't change instantly because I will not be infinite.
Okay, continue.
Hmm.
Okay, so let us see. Now these are the things which we have initially, and I got the initial values: I of 0 minus, I of 0 plus, V of 0 minus, V of 0 plus. Okay, now let us come to the second calculation. At t equal to 0 plus, the switch is open. Equivalent circuit is shown in this. This is the circuit. Okay, this is the circuit. You have R, L, C, all of them present. Now what we do, we are saying that immediately current in the inductor will not change, and current in capacitor is C dV by dt. That should be the current in capacitor. That means dV by dt is IC by C. Is that okay? Current in capacitor is C dV by dt. That means what is dV by dt? That is IC by C. So can I say dV by dt at 0 plus is IC at 0 plus divided by C? Is that okay?
Yes, sir.
And what
Yes,
is
sir.
IC at 0 plus?
2 ampere.
2 ampere. Why 2 ampere?
So we just
Because
calculated.
it was at 0 minus.
But that was inductor current, not capacitor current.
Sir, same
Due to
same
induction, the
current will
current will
charge.
not change
Yes.
instantaneously.
So that current which we calculated, which was inductor current, is same as capacitor current, same as resistor current. And because inductor current cannot change immediately, so the loop current will not change immediately. Okay. And that is how I calculated dV by dt with the help of IC 0 plus divided by C. Is it fine with everyone? Now look at the second calculation. If I apply KVL in this loop, so I say minus 12 plus voltage across resistor plus voltage across inductor plus voltage across capacitor should be 0. Is this okay?
Yes, sir.
We will now obtain, so minus 12. What is the voltage across resistor? 4 into I. What is the voltage across inductor? VL. What is the voltage across capacitor? VC 0 plus. Okay. Keep VL on one side, everything on the other side. So VL of 0 plus is 0. Okay. Now, what is the current what is the voltage across inductor? L di by dt. That means di by dt is V by L. This is valid for 0 plus also. Okay. So di by dt at 0 plus is voltage across inductor by L, and voltage across inductor was 0. So rate of change was 0. This is one thing that you should understand with clarity. How do I calculate the initial values of derivatives? This is the only difference as compared to first order analysis. Otherwise, the things will be very much similar. Okay. So after that, the third part we have already calculated, I infinity and V infinity. Now this is the question for all of you. Very quickly find all the quantities. I of 0 plus, V of 0 plus, I infinity, V infinity, di by dt 0 plus, dv by dt 0 plus. Okay, start calculating and verifying.
I zero
So
plus
when I look at I0 plus is
2.
2. Okay,
V 4. V 0 plus 4.
V0 plus is 4. So these are the things. Okay, then I infinity, V infinity also you can check. I infinity is simple, it will be 24 by 2, and V infinity will be 12 into 2, 24. Okay, now comes the part which is di by dt and dv by dt. Anyone who is able to cross check, please tell me.
40 dv by dt.
dv by dt you are saying 40, here the answer is 0.
Excuse me, sir.
Yes.
Sir, can you please explain that I0 and I infinity difference between them, sir? I'm having little bit of confusion. Why are we including 10 ohm in the first one and not in the second one?
When you say I0, I of 0 plus is same as I of 0 minus. Okay, I of 0 minus means from minus infinity to 0 minus, same conditions were prevailing. So it's a DC condition. And what is happening till 0 minus, this switch was open. Okay, when this switch is open, that means 10 ohm is being considered. After t equal to 0, when I will short circuit this one, 10 ohm is parallel to short circuit, it will not come in the calculation.
Okay, sir. Okay, got it. Thank you, sir.
Sir,
Yes,
sir, in option A, sir, when we calculate I zero plus, so in that we consider 10 ohm, but sir, there is also a wire which is showing
there is also
there- a wire where there is no resistance, sir. So sir,
true.
Yes, sir.
Downward.
it will be
Downward.
infinity.
Yes, sir. The whole circuit will be short circuited.
What you are saying,
Sir, this will be open.
this
Sir,
will
but
be
this,
open.
yes,
Fine. Okay, let us start putting the values. This is 0 volt. This is 24 volt. This is short circuit. This is 24. This is short circuit. This is 24.
Sir,
no,
neither.
sir, I'm telling that in I zero plus, sir, in that we consider 10 ohm. So sir, the current will directly go in the downward branch. It will not.
Downward.
It will not go through 10 ohm resistor.
Yes, sir. Like
Yes, sir.
0 is connected to like.
The 24 volt
Yes,
is also
sir.
short
Okay,
circuited.
okay. I think you are talking about this
Like
one.
the wire. Yes, sir. The wire is parallel to the connector.
But sir, when the current would be going back to voltage source, it need to pass through 10 ohm.
No, I don't think so.
Otherwise, won't be completed.
Okay, look at this. I think this part is a mistake.
Yes, sir. Then we can solve.
Yes,
Yes, sir.
I think this
Yes,
should
sir.
not be there. Okay, so let us move because we are having a lot of similar questions. One more question now we are having. So we are asking
Sir, in
again,
previous question, di by dt and dv by dt one same.
answers are written. You can cross check them. Okay, these are written. So let us move now. IL, VC, VR, DI by dt, dVC by dt. We are even asking dVR by dt, IL, VC, VR, infinity. Everything we are asking. Okay. Now look. This is 3 times ut. That means before t equal to 0, this is 0, and at t equal to 0 and onwards, it will be 3 ampere. So before I apply, means for 0 minus condition, what should be the value of IL 0 minus? But remember, this is not ut. Okay. So 0 ampere current source means open circuit for 0. Okay. Now consider this is VC. This will act like open circuit for infinity. So can anyone tell me what is IL, what is VR, what is all these things at 0 minus?
Sir, IL must be 0.
Sir,
IL,
IL 0. This is 0.
VR must also be 0.
IL 0 minus, you are saying 0.
0.
VR 0
VR 0 minus 0.
you are,
0.
and what about VC?
Sir, VC must
Minus
be
20.
minus 20.
Minus 20. Anyone else with any other answers? These are 0 minus. What about 0 plus?
Sir, 1 IL.
IL cannot change immediately. If it is 0 minus, it should be 0 plus also. Similarly, voltage across capacitor cannot change immediately. Only thing which can change is VR. Okay, so let us look at the solution. So we are saying for t less than 0, ut into 3 is 0. At t equal to 0 minus, circuit is in the steady state. So this is my circuit. Okay. So inductor is replaced by short circuit and capacitor is replaced by open circuit, and this is what I see. And the answers which we got, IL 0 minus, VR 0 minus, and VC 0 minus. Is it okay for everyone? Right?
yes,
Now,
sir.
although the derivatives of these quantities at 0 minus are not required, it is evident that they are all 0 because all these are constant quantities, so their derivatives will be 0. Okay, at 0 minus. Now we consider time t equal to 0 plus. 3 times ut will become 3, and capacitor is now equivalent to what we are showing here. So the circuit is now this. There is 3, and we are not opening the capacitor, we are not shorting the inductor also. Now only two things will be preserved. One is IL, one is VC. Okay. Now look at the voltage across 4 ohm. We can use it later, so we are just calculating it. Okay. So if I apply the KVL, KCL here, minus 3 divided by sorry, minus 3 plus VR by 2 plus VR minus or VO by 4. Okay, this is the equation. That means this is one equation I will keep. IL0 plus is equal to IL0 minus, VC0 plus is equal to VC0 minus. I think this is copied again. So now coming to KVL, we have to apply KVL here, here, and here. In the central mesh, when I apply the KVL like this, minus VR plus VO plus VC plus 20 equal to 0. Okay, minus VR plus VO plus VC plus 20 equal to 0. VC plus is known to us. Okay, so this is minus 20, this is plus 20. That means VR of 0 plus is VO of 0 plus. And now if I take, this is my equation number 2 and this is my equation number 1, 2 variable, 2 equations I can solve for VR 0 plus. Okay, now yes.
Sir, can you please go back to that image figure, sir? Sir, in this, as it is 0 plus, we can say that the inductor will open and the capacitor will short. So, sir, we can calculate I1 and I2.
So you are going to consider capacitor as short circuit.
And inductor will be open. It's 0 plus.
Why?
So, because this inductor doesn't allow, means the change of current, it opposes the instantaneous change of current. And capacitor will not work initially.
Okay.
Slowly the charges will develop on capacitor and it will become
Fine.
open circuit. But initially it
Okay.
will be short.
Yes, that is also one method of doing that. It can help in calculation of initial conditions. You can do that.
Okay.
Okay.
Sir, when we calculated VR and VO, V naught, sir, by doing that, current through 4 ohm resistor is going to be 1 ampere. Sir, from where that current is going to pass if IL is going to be 0?
No, no, no. This is the new current source which is added.
Yes, sir.
Okay.
Sir, then
So,
1 ampere current is going to flow through 4 ohm resistor.
okay, 1 is going here, 3 we are supplying. Okay, then.
No, sir, 1 through 4 ohm and 2 through 2 ohm.
Okay.
Sir, then how is the circuit going to be completed from the 4 ohm resistor? Where is the current coming back from?
It will come from here, this branch.
But sir, VC is still minus 20 volt there. The circuit.
See, the current in, what is the problem? Tell me. VC is something. What is I? I is equal to C dV by dt. And voltage have just started changing. How something will change if you are putting a force on that, right? Let me
Yes,
tell
sir.
you. Let me tell you. I is equal to C dV by dt. We are saying when V is constant, current is 0. Okay, but when V has slowly started changing, the effect or the change in voltage is not yet visible. That means V of 0 minus and V of 0 plus, they are still same, but change has started. And because change has started, that means dV by dt can be a defined number, right?
Okay, sir. Got it.
Okay. Now L di by dt is VL, so that means DIL by dt is VL by L. So how do I get voltage across inductor? So I will apply KVL in this mesh. That means VL minus 20 minus VC is equal to 0. Okay, that means VL is equal to VC plus 20. and VC0 plus is minus 20. That means VL0 plus is 0. So DIL 0 plus by dt is 0. Okay. Now, similarly, I is equal to C dV by dt for a capacitor, and that means dV by dt is IC by C. Now we should find out what is IC. So this one, either you apply a KCL here or you apply KVL and take IC equal to I1 minus I2. It is all your choice. And we got that VO is equal to IC plus IL. We applied KCL at that node. Okay. When we applied that KCL, then I have this value, I have this value, I will put them and I will get IC0 plus. Once I do that, then we can get dVC by dt also. Fine. How to get dVR by dt? You can go back and apply KCL here. This. Get the relation, and so this is the relation of KCL at that node. Now simply take the derivative. So d by dt of 3 plus d by dt of VR by 2 plus d by dt of VO by 4. You put those numbers, okay? You get one equation. Apply KVL in the middle mesh. We already did that. Our target is to get dVO by dt. Okay? We will take this again. I get one more equation. So one equation in dVR and dV, one equation in dVR and dV, one equation, second equation. Solve them, you get dVR by dt. Calculation of the initial values of derivatives is slightly tricky always. You should always try to find out KVL or KCL, how they will suit and how I am going to derive these values. Okay, there will not be any specific rule that how can I obtain the derivative initial values. Those things you will have to play with the circuit to obtain the values, and there is not a single way to get them. There will be always multiple ways to get those. Infinite values are easy. Once I have this circuit, and then I am saying this is always there, this is always there. Capacitor will act like open circuit, inductor will act like short circuit. Now can you tell me what is IL, VC and VR at infinity? Anyone who can tell me about IL?
1.
IL
1
will be
ampere.
1,
1
right?
ampere.
IL will be 1. 3 is coming, 2 will go here, 1 is going here. What is VC at infinity?
Minus 20 volts.
Minus
4.
20. VR
4.
2 into 2, 4. Okay. So these will be our values at infinity. IL infinity will be 1, VR will be 4, VC will be minus 20. There is a very similar question. This one, okay, please switch off the mic when you are done. This one is a very similar one. For your practice, please cross check all the answers. Okay. Now we will start that. Okay, fine, we are done with the initial values calculation, but how are we going to use them and where are we going to use them? So just like first order circuit, first of all we started our circuit analysis by considering source free circuits. And after that, we introduced the sources by saying unit step response. So same thing we will do here. We are saying somehow I have a capacitor which is charged and some initial current is flowing in the inductor. And then I disconnect those sources. And once those sources are disconnected, I have a source free circuit. Can you please analyze this circuit for me? That what will happen to voltage or current in this circuit throughout the time period? He says, okay, fine, we'll do that. So we are given that there are some initial condition, voltage across capacitor and current in the inductor. Now apply the KVL loop. Voltage across resistor is R into I. Voltage across inductor is L di by dt. And current in, voltage across this capacitor is 1 by C integration I dt equal to 0. Is this equation clear to everyone? How
Sir,
did
may
I?
you please explain again
Yes, sir.
what we are doing here?
See what we are doing? We are simply applying the KVL in this loop. So what is voltage across resistor?
IR.
IR. What is the voltage across inductor?
LDI by dt.
LdI by dt. What is the voltage across capacitor in terms of current?
Like,
1 by C integration I dt. Is that okay?
yes, sir.
Yes, sir.
Now what we say is because I have integration term, I should not keep. So let us differentiate. So when I differentiate, d r into I becomes, we should not have skipped that one. Let me write that. R into I will be R into di by dt plus LDI by dt differentiation will be L d square I by dt square. And what will be the integration of this term? 1
I
by
by
C, I by C, right? Now what I say, whenever you have the second order or any order differential equation, you should keep the coefficient of highest order as 1. So my highest order is d square I by dt square. So I will divide everything by L. So it becomes R by L di by dt. Okay. I by LC, I by LC and d square I by dt square. This is the second order differential equation that I got. Is this okay?
Sir,
Yes.
so in this circuit, we initially had some voltage source, and after infinity, we removed it, and then we are analyzing this circuit.
Yes. Then we are analyzing again. And now we are saying it is a source free circuit, and because there was some initial voltage and current and now there is no source, those voltage and currents will redistribute. Okay, they will redistribute and we have to see how they are behaving. So do you know the process of second order differential equation, how to solve them?
No, sir.
Yes, sir.
No.
No, sir.
No, sir.
Okay, in mathematics course you will study that, but let us also do that. Have you heard of Laplace transform?
No, sir.
Okay,
No.
no,
fine.
sir.
So no need to worry. So we said that whatever we got is a differential equation of second order. Okay, and that is the reason we are calling RLC circuit as second order circuits. Now our goal is to solve these equation. To solve second order differential equation, we require two initial conditions, such as the initial value of I and the initial value of first derivative of I, and some current and voltage values we will need. Okay, now look, when I talk about initial value calculation, I come back to this equation again. Okay, and I write it for 0 plus. Okay, that means R into I of 0 plus L di by dt plus V of 0. This is voltage across capacitor equal to 0. That means di by dt equal to 1 by L R I O plus V. Is this okay? Minus 1 by L. Is this okay? Fine.
Yes,
Do
sir.
you know the value of L? Yes. Do we know the value of R? Yes. Do we know I naught? Yes. Do we know V naught? Yes. That means I can calculate di by dt at t equal to 0 plus. When we will have actual circuits, we will put the values and we can calculate those. Now, I have a second order differential equation, and solving second order differential equation, there can be a lot of methods. This is one of the methods we are using. I am assuming that my circuit is this, my equation is this: d square I by dt square plus r by L di by dt plus I by LC equal to 0. This equation will have some solution. That means I is equal to something plus something plus something. Okay. I am assuming that, let me say that I is equal to A into e raised to power st is my solution. Okay. So wherever is I, replace I with A e st. So now look at d square I by dt square. If you put I is equal to A e raised to power st, what will be the second differential of this term?
S
A
into e
square
raised to
x square into e raised to power s.
Is it fine? A into s square e raised to power st.
Yes, sir.
Okay. Next, my next term was r by L di by dt. That means r by L and d by dt of A into e raised to power st. So that will be A into r by L e raised to power st. Is this okay?
Sir, can you explain I wala part once again?
Yes, sir. From starting, I is equal to AES.
Yes.
We are saying just assume that I will come as A into e raised to power st, where A is a constant that we will identify and S is in the Laplace domain. Okay. So
Okay,
we will
sir.
calculate that. We will calculate what is the value of S, what is the value of A. Okay. E raised to power 5t, e raised to power minus 2t, something. Because what we are saying, when the source is not there, the current will exponentially increase or decrease. Voltages at some points will exponentially increase or decrease. We are assuming this exponential function, e raised to power st. Okay. And it will have some constant A. This is what we have seen till now, right? That all the voltages and currents, they are increasing or decreasing exponentially. So there is no harm in assuming that my answer will be one exponential value, A e raised to power st. Is that okay? Now what I am doing, I have my differential equation. Let me write it here. D square I by dt square plus R by L di by dt, this is I, plus I by LC equal to 0. In this equation, put I is equal to A e raised to power st. So what is d square by dt of A e raised to power st? That is A s square e raised to power st. Is that okay?
Yes, sir.
Plus R by L into A s e raised to power st plus A e raised to power st by LC, LC equal to 0. That is the equation I got. Any issues till this point?
No, sir.
Okay, now after that the next line is also clear to everyone, that a into e raised to power st is common and remaining things are under the brackets, right?
Okay, sir.
Now look at this. This is product of two terms equal to 0. This term, if I make it 0, that means my solution itself is 0. So this is not 0. That means definitely this is 0. Is that okay now?
So slide is not visible.
Sir,
Please
last
scroll down
part
a
is
bit.
मतलब थोड़ा कटा
Last
हुआ है.
part.
Okay, wait. First of all, slide is visible or not?
Sir, please
Sir,
scroll down
slide
that.
is
Slide
visible.
is
Sir, it is a
visible.
complete slide.
Fine,
Sir,
fine, fine.
scroll down.
Okay, don't
Yes,
worry,
sir.
don't worry. Cry. Now, now is it fine?
Yes, sir.
So what I have done, a into e raised to power st, I have taken common, and everything else in the bracket. Everything else in the bracket into a into e raised to power st, the product is 0. That means a into e raised to power st is not 0. That means the other thing is 0. Is that fine?
Yes, sir.
Okay, everyone. So I am going to present again. Is the slide visible now?
No, sir, it's showing
No,
black
sir.
screen.
No, sir.
Okay.
Okay, so let us try again. Now,
Yes, sir. Yes,
Yes.
sir, it is visible.
right. So what we say, that a into e raised something is going wrong. Whenever I press slideshow, I am getting out of the meeting. Okay. Now, please let me know if the slide is visible.
Yes, sir.
Yes,
Sir,
sir.
it's
Yes, sir, it
visible.
is visible.
Yes, sir.
Okay. So now we said that a into e raised to power st times this equal to 0. A into e raised to power st is definitely not 0, because that is what we are assuming as our answer. If answer is 0, why are we solving? That means s square plus r by l s plus 1 by lc is equal to 0. Now this is a very simple quadratic equation in s, and you can very easily calculate that it is a quadratic equation. It will have two roots. One is s1, one is s2. Is it clear?
Yes, sir.
Yes, sir.
Now we are saying, because these terms are becoming very large, let us have some new variables, and I define alpha as r by 2l and omega naught as 1 by root of lc. When I take them, then these equation, which is r by 2l, means alpha plus alpha square minus omega naught square, minus alpha minus alpha square minus omega naught square. So what is S1 and what is S2? These are the things where alpha is this and omega naught is this. One more thing you can do is, if you write this equation in terms of alpha and omega naught, you can write it as s square plus 2 alpha s plus omega naught square equal to 0. Is that okay?
Got it, sir.
Okay. Now what are we saying? That my current, which I was assuming as a into e raised to power st, there are two values of s, s1 and s2. That means my total value will be a into e raised to power s1t plus a2 into e raised to power s2t. Okay, this will be my total current. Is this okay now? S1 and S2 I have already calculated. S1 and S2 I have already calculated. Now my focus is only on the calculation of A1 and A2. And let me tell you very simple way of calculating A1 and A2. How can you calculate A1 and A2? Put t equal to 0. That means I of 0 will be A1 plus A2. Is this okay?
Yes, sir.
See, e raised to power s1t, t is 0, e raised to power 0 is 1, e raised to power 0 is 1. That means I of 0 is a1 plus a2. We know the value of I of 0. It was given as inductor current, right? I got one equation. Now what I do, I take this equation again and I differentiate. That means di by dt equal to, what will be that? A1 s1 e raised to power s1t plus a2 s2 e raised to power s2t. Now again take the value at 0. So what will be that? di0 by dt equal to a1 s1 plus a2 s2. This is my second equation. You know the value of s1, you know the value of s2 already. Two equation, two variable. Can you calculate a1 and a2?
Yes, sir.
Yes, sir.
So now everything is coming into one picture. How did we started? So let me show you here also. So I will have this equation, then I will have two answers, a1 s1t, a2 s2t, and total current will be a1 s1t plus a2 s2t. One more thing, let us, I did not discuss it because first I wanted to tell you the easy solution. Now your life in quadratic equation is not very simple, because that will depend on what type of roots you are getting, whether you are having this factor greater than 0, equal to 0, or less than 0, right? Because if it is greater than, equal to, or less than, then it will decide what type of roots are you going to get. Are you getting simple real distinct roots, or equal roots, or complex roots? Is it okay? That will only change the value of S1 and S2. The remaining process will remain same. So now if I have three situations, that means if alpha is greater than omega, equal to omega, or less than omega, the term which was alpha square minus omega square, then it will decide three cases. So first case, I am assuming alpha is greater than omega. Alpha is greater than omega, that means I will have C greater than this, and I will get two roots, both are negative and real. And this is my response. Once I get this, how do I start with that? Second case is if alpha is omega. If alpha is omega, C is equal to this, and S1 and S2 both will be same, equal to only minus alpha. Okay. In that case, my complete solution, which was a1 e raised to power st plus a2 e raised to power st, it will be summation of this, and it will be a3 e raised to power st, where s is minus alpha. Okay. Now what we are saying, this cannot be the solution because two initial condition cannot be satisfied with single value of a3. Okay. So whenever you get equal roots, that means alpha is equal to omega naught. This is the derivation of proving. In mathematics, you will have a lot of these things. We are just proving that simple assumption of alpha equal to omega and taking only single root and saying both of them having same values. That will not work. We are just proving it. Okay, in these slides we are just proving it. We will never ask it in basic electronics, but definitely you will be asked in mathematics, and I am leaving for that course. We are saying whenever alpha is equal to omega naught, my solution will be this: a1 t plus a2 into e raised to power minus alpha t, or sorry, plus alpha t. Okay, so this will be, it should be minus alpha only. It is a mistake here. Okay, so third case, when alpha is less than omega, that means I get complex conjugate pairs, and I will put s equal to this. When I do that, I get, do you remember Euler's formula?
Yes, sir.
Okay, so let me just see how much time is left. We are already done, so let me just quickly wrap up. We will come back to these. Okay, don't worry. E raised to power j theta, how can you write that? Cos theta plus j sin theta, is that okay? E raised to power minus j theta is cos theta minus j sin theta. We can write that, right?
Yes,
So
sir.
here it is e raised to
Yes,
power
sir.
j omega d, e raised to power minus j omega d. I will write them in terms of sine and cosine. It will go on and we keep on solving, and finally we get this. Okay. So what are we saying till now? That if I have a quadratic equation based on the value of alpha and omega, I can have three cases. And any case, these are just explanation of those things what we are speaking. And next time we will start with the calculations. Okay, I am going to upload this slide along with the example. This example also I am going to upload. We will cover it tomorrow, but I will, tomorrow means Monday, but please go through this example. Okay, please go through this example, and then you see what is happening. If you understand, good. If you don't understand, then also good. We are going to solve it in next lecture. Okay.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Right
sir.
to find,
Thank you, sir.
Thank you, sir.
right everyone.